This conference will now be recorded.
I'm audible to you. Good evening. So far, we have discussed indefinite integrals. In today's class, we are going to learn about definite integrals. There are various methods to solve indefinite integrals that we have discussed in the previous classes. Okay, so today we are going to study about definite integrals. Definite integral is of the form integral a to b f of x dx. Okay, where a is the lower limit of x and b is the upper limit of x. Here the variable is x. What is f of x? F of x is called as an integrand. Okay, here the integrand is f of x. We are going to integrate f of x with respect to x between the limits a and b. So in definite integrals, you will be having limits, upper and lower limits. Okay. There is a procedure for evaluating definite integrals. It is given here. We can evaluate by using substitution method. We can evaluate the given definite integrals using substitution method. Substitution method already we have learned. What we have done, we have to use the substitution either y equal to f of x or x equal to g of y. That is, we have to transform the given variable x to a new variable, say y. Okay, then we will integrate the new integrand. We will integrate the new integrand with respect to the new variable. Okay. Then we will substitute the limits. After substituting the limits, then we have to, before going to substitute the limits, we have to change the new variable to the original variable. Then we have to substitute the limits. This is the procedure. So first, what we will do is we have to use substitution. Okay, we have to use the substitution. Then we have to integrate it with respect to the new variable. Then we will change the new variable to the old variable. Then we will apply the limits. Let's see one example. Evaluate integral from -1 to 1 pi x to the power 4 into square root of x power 5 plus 1 dx. So what is the integrand here? Here the integrand is 5x to the power 4 into square root of x power 5 plus 1. So your f of x is 5x power 4 into square root of x power 5 plus 1. It's a function of x. So we are going to integrate this with respect to x between the limits -1 and +1. What is the lower limit? Lower limit is -1 and upper limit is +1. Okay. How we are going to evaluate this integral? By using substitution method. Okay, here what substitution you are going to use? X power 5 plus 1 equal to t. Because we know that the differentiation of x power 5 is 5x to the power 4, that is present in the integrand. Okay, that is present here. 5x power 4. X power 5 differentiation respect to x is 5x power 4, that is here. So I am going to take x power 5 plus 1 as t. X power 5 plus 1 as t. Okay, now differentiate with respect to x on both sides. We'll be getting dt equals 5x to the power 4 dx. Okay, therefore, the above integral becomes, what is 5x power 4 dx? It is dt. Okay, what is square root of x power 5 plus 1? It is t. So you will have square root of t dt. Square root of t dt. What is square root of t? This is nothing but t to the power half. So what is integral t power 1 by 2 dt? On integrating, we get e to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay, on integrating, we get t power half plus 1 by half plus 1. What is t power half plus 1? This is, if you simplify, then you will get 2 plus 1 by 2. It is 3 by 2. So t to the power 3 by 2 divided by 3 by 2. This is t power 3 by 2 divided by 3 by 2. So if this comes to the numerator, then you will get 2 by 3 t to the power 3 by 2, or 2 by 3 into what is t? Now I have to replace the new variable by the old variable. Okay. Now t is replaced by x to the power 5 plus 1. Okay, what is t? What is my t is x power 5 plus 1. So x to the power 5 plus 1 whole to the power 3 by 2. Okay. Now I am going to substitute the limits for x. Okay. For what we have to substitute the limits? X between minus 1 and plus 1. How will you substitute? F of b minus f of a. Okay. Substitute the upper limit, then minus, then substitute the lower limit. That is the procedure. F of b minus f of a. Okay. So substitute the upper limit. What you will get? 1 power 5 plus 1. 1 power 5 is 1. So 1 plus 1, 2. 2 to the power 3 by 2. Okay, in upper limit, I am getting 2 power 3 by 2. Then minus. Okay, we'll have minus in the middle. So minus. Now substitute the lower limit. What is the lower limit? Minus 1. Okay, we have to substitute it for x. Okay, so substitute x equal to minus 1. What is minus 1 whole power 5? It is again minus 1. So minus 1 whole power 5 plus 1 whole to the power 3 by 2. What is minus 1 whole power 5? It is again minus 1. So minus 1 plus 1 is 0. So in the lower limit, I am getting 0. Okay. So the leftover term is 2 to the power 3 by 2. Okay. So 2 by 3 into 2 to the power 3 by 2 can be written as 2 into square root of 2. 2 to the power 3 by 2 is 2 to the power half into 2, right? Into 2 power 1. So this can be written as 2 into square root of 2. So what you are getting is 4 into square root of 2 by 3. Okay. Any doubts in this problem? Are you all able to understand? There is an alternate way to evaluate this definite integral. What is that? Here, first I have used the substitution method. Then I have replaced the dummy variable. After that, I have substituted the limits. Okay, this is one of the way. The other way is, when you use substitution method, you can change the corresponding limits also. There itself, you can change the limits. Okay, because we are using a transformation. We are transforming from one variable to another variable. So we have to change the limits also. Okay. What is your substitution actually? T equal to x to the power 5 plus 1. And dt is 5x to the power 4 dx. Here also we are using the same substitution method only. But what is the difference here? After using substitution, we are changing the corresponding limits also. Okay, that is the difference here. What are the limits of x? Minus 1 and plus 1. Minus 1 is the lower limit and plus 1 is the upper limit. That is given in the problem. Okay, so I'm going to change the limits now. When x takes the value minus 1, what is your t? When x is minus 1, what is t? That I have to find. Okay. So when x takes the value minus 1, t will take 0. How? You substitute x equal to minus 1 in this transformation. Okay. If you substitute x equal to minus 1, here, then you will get minus 1 whole to the power 5. What is minus 1 whole to the power 5? It is minus 1 again. So minus 1 plus 1 value is 0. Okay. Therefore, t takes 0. So when x takes minus 1, t takes 0. Similarly, when x takes 1, upper limit is 1. What is your t? Calculate. Substitute x equal to 1 in the transformation. You will get 1 to the power 5. 1 power 5 is again 1. So 1 plus 1 is 2. Therefore, t is 2. Okay. Now my upper limit is 2. Lower limit is 0. Okay. Now the limits are changed. Therefore, we have integral 0 to 2. Lower limit is 0, upper limit is 2. The same integrand. Okay, you'll maintain the same integrand. So integrand is square root of t dt. On integrating, you will get t to the power 3 by 2. Now substitute the new limits. What are the new limits? 0 and 2. Okay. Substitute the upper limit. Okay, first you will substitute the upper limit. So you will get 2 to the power 3 by 2 minus, substitute the lower limit. What you will get? 0 power 3. So what you are getting is 2 to the power 3 by 2. That can be written as 2 into square root of 2. So the final answer is 4 into square root of 2 by 2. Okay, this is another method. The next problem is evaluate integral 0 to 1 tan inverse x divided by 1 plus x square dx. So what is your integrand here? Your integrand is tan inverse x by 1 plus x square. Okay, tan inverse x by 1 plus x square. Let t equal to tan inverse x. Why we are using this substitution t equal to tan inverse x? Because we know that the differentiation of tan inverse x is 1 over 1 plus x square. Differentiation of tan inverse x is 1 by 1 plus x square. So I have taken tan inverse x equal to t. Okay, if I take tan inverse x equal to t, then I can replace 1 over 1 plus x square. Okay, now differentiate with respect to x on both sides. So you will get dt is equal to 1 over 1 plus x square dx. Now find the limits. What are the new limits? When x takes 0, what is t? Substitute x equal to 0 here. Tan inverse 0. Okay, what is tan inverse 0 value? It is 0. How it is 0? This is tan inverse in tan. For what angle this you will get 0? Tan 0 is 0, right? Tan 0 is 0. So tan inverse and tan will get cancelled. You will get 0. So t value is 0. Okay. So t equal to tan inverse 0 is equal to 0. Right? So that is your lower limit. What will be your upper limit? What is the upper limit given in the problem? 1. Okay. So now I am going to substitute x equal to 1 here. I am going to substitute x equal to 1 here. So t equal to what you will get? Tan inverse 1. Right? Tan inverse 1. In tan, for what angle you will be getting 1? Tan pi by 4 or tan 45 degree is 1. That we know already. Yes, we have studied. Tan 45 degree or tan pi by 4 is 1. So tan inverse, this 1 can be replaced by tan pi by 4. Okay, that 1 can be replaced by tan pi by 4. This one. Tan inverse of tan 45 degrees 1. So tan inverse of tan pi by 4. Now this tan and tan inverse will get cancelled. So what is remaining? Pi by 4. So this will be your upper limit. Okay. When x takes 0, t is 0. When x takes 1, t is pi by 4. Okay. Now when x varies from 0 to 1, t varies from 0 to pi by 4. Therefore, the new limits are 0 and pi by 4. Okay. Therefore, what are getting? Tan inverse t is equal to, tan inverse x is t, and dx by 1 plus x square is replaced by dt. Okay. So t dt. T is your new integral. Now integral t dt. Integrate t with respect to t. You will be getting t square by 2 between the limits 0 and pi by 4. Okay. Now substitute the limits. For what we have to substitute? T. Okay. So pi by 4. Now the variable is t. So pi by 4 the whole square divided by 2. Or you can take 1 by 2 outside as common, because It's a constant, so we can take it out. So pi by 4 the whole square minus what is your lower limit? 0. Okay, we have to substitute for t now. So 0 by 2 is 0. So pi by 4 the whole square by 2. Therefore pi square by 16. 16 into 2 is 32. So pi square by 32. That is the answer. Final answer. Any doubts? Some exercise problems are given in our book. You can try that. I will do more number of problems. First, we discuss some properties of definite integrals, then we do problems. Okay, based on that. Some properties, important properties of definite integrals are listed here. Some important properties of definite integrals. While doing problems, we will use these properties. Okay, so what are the properties? See the first property. Integral a to b f of x dx equal to integral a to b f of t dt. This property says what? Integral a to b f of x dx equal to integral a to b f of t dt. We can change the variable x to a new variable t. That is, here we are using substitution method. Okay, that is understood here. So when we use substitution method, the given variable is changed to a new variable. When we use transformation or substitution, then the given variable, then the given integral will get reduced to a new integral. Okay. That is the first property. And second property is integral a to b f of x dx equal to minus integral b to a f of x dx. So from this property, it is clear that we can, when we change the limits, actually here the limits are a to b f of x dx, integral f of x dx, x varies from a to b. Suppose I want to change the limits from b to a, then I have to put minus. Okay. By using this property, I can put minus and then I can change the limits also. Whenever you want to change the limits, you can put minus and you can change the limits. So minus integral b to a f of x dx. In particular, integral a to a f of x dx equal to 0. It is obvious because here the lower limit and upper limit are same. Both are equal. Therefore, the integral value will also be, the integral value is 0. Okay. When the lower limit is equal to the upper limit, then the integral value will be 0. Then what is the next property? Integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx. What does it mean? What are the limits of x? A to b. Okay. That means x lies between a less than or equal to x less than or equal to b. That is, this is x, a less than or equal to x less than or equal to b. That means x belongs to the closed interval a comma b. Okay. Here my integrand is f of x. X belongs to the closed interval a comma b. Therefore, we have a less than or equal to x less than or equal to b. The meaning of this one is a less than or equal to x less than or equal to b. X lies between a and b. A is the lower limit and b is the upper limit. Okay. If there is any point in between a and b, a less than or equal to, if I take any point in between a and b, okay, say c, then I can write integral a to c plus c to b. Integral a to c f of x dx plus integral c to b f of x dx. That's what property number 3. Okay. Next property is integral a to b f of x dx is integral a to b f of a plus b minus x dx. Okay. Here x is transformed into a plus b minus x. So integral a to b f of x dx is integral a to b f of a plus b, sum of the upper and lower limits, a plus b minus x dx. That is the next property. Then integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. This is a particular case of the above property. Why it is a particular case? This will belongs to this one. So it's a particular case. How it belongs? Here we have taken from A to B. Okay, x varies from A to B. Here we have considered x varies from 0 to A. Okay, so sum of the upper and lower limits. So if you consider the sum of upper and lower limits, then you will get 0 plus A. 0 plus A is A. Therefore, f of A minus x. Actually, you will have f of 0 plus A based on the above property. Okay, 0 plus A minus x. What is 0 plus A? It is A. So A minus x, f of A minus x dx. That is what? Property number 5. Okay, here it is P4. Next property is integral 0 to 2a f of x dx. Integral 0 to 2a f of x dx is, how can we write this? Integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay. 0 to 2a can be separated into two integrals. Integral 0 to 2a f of x dx can be separated into two integrals, namely integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay. Next one is integral 0 to 2a f of x dx is 2 times integral 0 to a 2 times integral 0 to a f of x dx if f of 2a minus x equal to f of x, and 0 if f of 2a minus x equal to minus f of x. This is one of the important property. Integral 0 to 2a f of x dx equal to 2 times integral 0 to a. Okay, here we have 2a, in the upper limit we have 2a. This can be written as 2 times integral 0 to a f of x dx provided f of 2a minus x equal to f of x. And if f of 2a minus x equal to minus f of x means then the integral value will be 0. Okay. The next property is, this is the last property. Integral minus a to a f of x dx equal to 2 times integral 0 to a f of x dx if f of x is an even function of x. What do you mean by even function? How we can check whether the given function is an even function or not function of x? Replace x by minus x. Replace x by minus x. If you return the same function again, f of x, okay, then f of x is said to be an even function of x. Okay, the given function is f of x. Now we are replacing x by minus x. When you replace x by minus x, if you get the same function again, then the given function is said to be an even function of x. Otherwise, it is an odd function of x. What is the other case? Odd function means if you replace x by minus x, then if you get minus f of x, this is the condition. F of minus x, when you replace x by minus x, if you get minus f of x, then the given function is said to be an odd function of x. For example, f of x equal to x square. This is my given function. Now I am going to replace x by minus x. Wherever you have x, replace it by minus x. So what you will get? Minus x the whole square. Minus x the whole square is again x square only. So now I am getting the original function again. This is nothing but f of x. So what I have got here? F of minus x equal to f of x. Therefore, x square is an even function of x. If it is an even function, if the integrand is an even function, then I can change the limits. Okay, the limits are minus a and plus a. from minus a to plus a. Okay, if the function is an even function, then I can write 2 times integral 0 to a. 2 times integral 0 to a. Okay. This is example for an odd function x square minus x. Now you replace x by minus x. So what you'll get? Here you will get minus x the whole square. Here you will have minus of minus x. Wherever you have x, replace it by minus x. So what you are getting? Minus x the whole square is x square. Okay, this is minus minus plus, so plus x. How this can be written as this is minus of minus x square plus x. So actually here this condition is not satisfied. Let's take another example. F of x equal to x cube. So if we replace x by minus x, what will get? Minus x the whole cube, right? What is minus x the whole cube? Again, minus x cube. Minus x cube. So this can be written as minus f of x. X cube is replaced by f of x. So minus f of x. F of minus x equal to minus f of x. Therefore, it is an odd function of x. If the integrand is an odd function of x, then the value of the integral will be 0. Okay. That is the last property. Even sin x, if you consider sin x is an odd function because sine of minus theta is minus sine theta. Replace x by minus x, so we will get sine of minus x. What is sine of minus x? Sine of minus theta is minus sine theta, so minus sine x. Okay, this can be written as minus, what is sin x? Sin x is f of x. So minus f of x. So what you are getting is f of x equal to, f of minus x equal to minus f of x. Therefore, sin x is an odd function of x, whereas cos x is an even function of x. Okay. So even function means 2 times integral 0 to a. Odd function means the value of the integral is 0. That's what property number 7. Proofs are not required. You can go through the properties. You can solve problems based on the properties. See this problem, evaluate integral minus 1 to 2 modulus x cube minus x dx. Evaluate integral minus 1 to 2 modulus x cube minus x dx. First identify that whether the given integral is a definite integral or an indefinite integral. It's a definite integral because here we have limits, right? So it's a definite integral. Now see the integrand. What is the integrand? F of x is modulus x cube minus x, absolute value of x cube minus x. So absolute value means you have to check whether the given function takes positive values. When the given function will take positive values in the given range, that you have to check. What's the definition of modulus x that you know? Modulus x is x. Modulus x will be x, that is positive, if x takes positive values. If x greater than or equal to 0. Okay. And minus x if x takes negative values. This is the condition. This is the definition of modulus x. X is less than 0. Okay. So first we need to check that the given function, when the given function takes positive values in the given range, and when the given function will take negative values in the given range, that we have to check because the integrand is the absolute value of x cube minus x. Otherwise, you need not to check. Okay. Why we are checking? Because the integrand is the absolute value of x cube minus x, modulus x cube minus x. Because modulus x definition is x if x takes positive values. Positive values means in the positive range from 0 to infinity. The real line in 0 to infinity, that is for positive values of x, x will take positive values. If x takes negative values, that is from minus infinity to 0. Okay, in the negative side, x will take negative values. That is the definition of modulus x. So we have to check it. X cube minus x is greater than or equal to 0 in minus 1 comma 0, and x cube minus x is less than or equal to 0 on 0 comma 1, closed interval 0 comma 1, and x cube minus x is greater than or equal to 0 on closed interval 1 comma 2. Here the given interval, what is the given interval? Closed interval minus 1 comma 2. This is the given range. X belongs to minus 1 comma 2. This interval is separated into three intervals, three sub-intervals. Okay, minus 1 comma 0, 0 comma 1, 1 comma 2. Minus 1, 0, 1, 2. This is your given interval. Here the given range, given interval is divided into three sub-intervals, namely minus 1 to 0, 0 to 1, and 1 to 2. Why? Because in minus 1 comma 0, my function takes positive values. In 0 comma 1, my function takes negative values, and 1 comma 2, in 1 comma 2, the integrand takes positive values again. That we have to check. Okay, how to check this? You substitute minus 1 here. Okay, if x takes minus 1, what will happen? Minus 1 cube minus 1. Minus 1 cube is minus 1, minus 1. Sorry, minus of minus 1, right? Here we have one minus. So if we substitute x equal to minus 1, then it becomes plus. So minus 1 plus 1 is 0. It's a positive value. Okay. Here I have substituted x equal to minus 1. Okay, I'm going to substitute minus 1 by 2 or minus 0.5 for x. So minus 1 by 2 whole cube. Then minus of minus 1 by 2. Minus of minus 1 by 2. What is minus 1 by 2 whole cube? It is minus 1 by 8. This is minus of minus plus. So plus 1 by 2. Okay. So what is the common denominator? 8. So minus 1 plus, here I have to multiply the numerator by 4. So what I'm getting? 3 by 8. It's definitely greater than 0, positive value. Okay. So in this interval, this function takes only positive values. For x equal to minus 1, it takes 0. For x equal to minus 1 by 2, it takes 3 by 8. For x equal to 0, the function value is 0. Okay. Similarly, you can check the other ones. Here it is given that x cube minus x is less than or equal to 0 on closed interval 0, comma 1. How to check this? Substitute x equal to 0. So you will get 0 minus 0, it is 0. And substitute 1. 1 minus 1, 0. Or you can substitute 1 by 2. So 1 by 2 whole cube minus 1 by 2. This is 1 by 8 minus 1 by 2. Okay. So the common denominator is 8. 1 minus, what should I multiply here? 4. So what you are getting? Minus 3 by 8. So you are getting negative value in this range. Here the function takes negative value in this range, and that x cube minus x is greater than or equal to 0 on closed interval 1, comma 2. Therefore, the above integral can be separated into three integrals, namely integral minus 1 to 0 plus 0 to 1 plus 1 to 2. In minus 1 comma 0, the function is x cube minus 6 respect to x. In 0 comma 1, the function is minus of x cube minus 6 with respect to x. In 1 comma 2, it takes positive values, so x cube minus x dx. Okay. So what you're getting is integral minus 1 to 0 x cube minus x dx. Bring this minus inside the bracket, so minus x cube plus x. So x minus x cube integral 0 to 1 x minus x cube dx plus integral 1 to 2 x cube minus x dx. On integrating, we get x to the power 4 by 4 minus x square by 2 between the limits minus 1 and 0. If you integrate this, then you will get x square by 2 minus x to the power 4 by 4 between the limits 0 and 1. Here you will get x to the power 4 by 4 minus x square by 2 between the limits 1 and 2. Okay. Are you all able to understand? Now substitute the limits. In the upper limit, this will be 0. In the upper limit, what is the upper limit? 0, right? So in the upper limit, the entire term will become 0 because we have x. We have to substitute for x, right? Okay, so if you substitute, then then the entire term will vanish. Okay, now substitute the lower limit. How will you substitute? Upper limit minus lower limit. So upper limit is 0. In the upper limit, I am getting 0. So 0 minus lower limit. Open the bracket, substitute the lower limit. Minus 1 power 4 is 1. 1 minus 1 power 4 is 1. So 1 by 4 minus 1 square is again 1. So 1 by 2. So what you're getting in the lower limit? 1 by 4 minus 1. Now come to the second one. Substitute the upper limit. So you'll get 1 by 2 minus 1 by 4. The lower limit, the entire function will become 0. So upper limit minus lower limit is actually what? 0. Okay. Here, if you substitute the upper limit, what you will get? 2 power 4. What is 2 power 4? 2 power 4 is 16. 16 by 4 is 4 minus 2 square. 2 square is 4. So 4 by 2 is 2. This is your upper limit minus lower limit. Substitute the lower limit. So 1 by 4 minus 1 by 2. Now simplify the terms. The answer is 11 by 4. Okay, the next problem is evaluate integral minus 5 by 4 to plus 5 by 4 sine square x dx. Okay. Now see the integral, we have sine square x dx. Okay, so while you are evaluating definite integrals, you have to check the integral, whether it is an even function or an odd function, or can we use any other property here. Okay, or directly we can go for substitution method. Now to think all the options. Right? So here my integrand is sine square x. Obviously, it is an even function of x because we have square term here. Let us check. What is your f of x? Your f of x is sine square x. Okay. Now replace x by minus x. So sine square of minus x. Since we have square here, sine square of minus x is actually minus sine theta. This minus square. So this will become sine square x. Okay. So sine square x. Again, you are getting the same function when you replace x by minus x. Therefore, it is an even function of x. Even function means what is the property? The property says we can change the limits from 0 to a. What is a here? Pi by 4. 2 times 0 to a. That is the property. Okay, so 2 times integral 0 to pi by 4 sine square x dx. 2 times integral 0 to pi by 4 sine square x dx. Okay. Now we are going to evaluate this integral 0 to pi by 4 sine square x dx. So how to evaluate this? By using the formula. What is the formula for sine square x? It is 1 minus cos 2x. So 1 minus cos 2x by 2. This 2 and 2 will get cancelled. So 1 minus cos 2x dx. On integrating, we get x minus, what is integral cos 2x? Sine 2x by 2. Between the limits 0 and pi by 4. Now substitute the limits. What you will get? Pi by 4 for x we are substituting. So pi by 4 minus 1 by 2 sine 2 pi by 4. 2 pi by 4 becomes sine pi by 2. When you substitute the upper limit, you will get pi by 4 for x. Okay, so pi by 4 minus 1 by 2 sine 2 pi by 4. So this will get cancelled. What are you getting? Sine pi by 2. So pi by 4 minus 1 by 2 sine pi by 2. In the upper limit. In the lower limit, if you substitute 0, here since we have x here, you substitute 0, then this will become 0. Minus, what is the value of sine 0? Here if you substitute, you will get sine 0, right? Minus 1 by 2 sine 0. So minus 1 by 2 sine 0. We know that the value of sine 0 is 1. This is your upper limit minus this is your lower limit. Sine 0 is 0, so the entire term is 0 in the lower limit. So this is the answer. Simplify, sine 90 value is 1. So pi by 4 minus 1 by 2 is the answer. You can further simplify, you can take the common denominator as 4. So pi minus is the answer. Is it clear to you? See the next problem. Evaluate integral 0 to pi x sin x by 1 plus cos square x dx. X sin x by 1 plus cos square x dx. What is the integrand here? X sin x by 1 plus cos square x. See the limits. It is of the form integral 0 to a f of x dx. Integral 0 to a f of x dx. Here I am going to use the property number 4. What is property 4? Property 4 says integral 0 to a f of x dx is integral 0 to a f of a minus x dx. Here we can use this property. Okay, 0 to a f of x dx is 0 to a f of a minus x dx. Zero to a f of x dx equal to 0 to a f of a minus x dx. Based on this property, actually this is of the form 0 to a f of x dx, right? What is our a? Pi. So 0 to a f of a minus x. In the place of x, we have a minus x in the right hand side. So wherever you have x, you replace it by a minus x. Okay, wherever you have x in the integrand, then you have to replace it by x minus, a minus x. What is your a? You first identify that a is pi. So pi minus x. So x is replaced by pi minus x. Is it clear? This is replaced by pi minus x. Replace it. So pi minus x, sine of pi minus x divided by 1 plus cos square into cos square of pi minus x dx. Pi minus x, sine of pi minus x by 1 plus cos square of pi minus x dx. So this is pi minus x. What is sine of 180 minus theta? This is the form sine of 180 minus theta. Pi is 180, right? Sine of 180 minus theta is sine theta. So you'll get sine x. Pi minus x sine x dx divided by 1 plus cos square of pi minus x. Cos square of pi minus x. Cos of 180 minus theta is also cos x. In 180 degree, the angle will not change, right? So you'll get again cos square x. Pi minus x sin x dx by 1 plus cos square x. Okay. So now I am going to integrate this. What is your I? Integral 0 to pi x sin x. So actually this can be separated into two integrals. One is pi sin x. Okay. Pi sin x dx. Pi is a constant, so take it out. Integral 0 to pi. This pi into sin x. You multiply these two. So pi into sin x. Pi is a constant, take it out. Divided by 1 plus cos square x. Okay, then you multiply these two. Minus x sin x. So minus integral 0 to pi x sin x dx divided by 1 plus cos square x. Right? This 0 to pi integral 0 to pi x sin x dx by 1 plus cos square x can be replaced by I, because we have assumed that the given integration as I. Okay, so what are having? Pi integral 0 to pi sin x dx by 1 plus cos square x minus the second integration can be taken as I, because initially we have assumed that I, that one is I. Okay, so this is replaced by I. And this side we have I, right? The left hand side we have I. So if you bring this I to the left hand side, then it will become 2i, I plus I 2i. So what is the value of 2i? 2i is pi integral 0 to pi sin x dx by 1 plus cos x. Therefore, I value is pi by 2 integral 0 to pi sin x dx by 1 plus cos x. So this is your problem now. So now your problem is, this is actually your problem, right? Now your problem is getting reduced to, getting simplified to the new one. Pi by 2 times integral 0 to pi sin x dx by 1 plus cos x. How to integrate this one? By using substitution method. What substitution we can use here? We know that differentiation of cos x is sin x. We have cos square x in the denominator and sin x dx in the numerator. So I am going to assume cos x as t, because the differentiation of cos x is sin x, that is present here. So I am going to take cos x equal to t. You take cos x equal to t, then what you will get? What is the differentiation of cos x? Minus sin x. Okay, differentiation of cos x is minus sin x dx equal to dt. Now we have to change the limits also. Okay. When x takes 0, what is the lower limit of x? 0. What is the lower limit of x? 0. What is the upper limit of x? Pi. So when x takes 0, substitute x equal to 0, what do you get? Cos 0 value is 1. Here you have to substitute cos 0. Okay, cos 0 value is 1. So t is 1. Okay, when x is 0, t is 1. When x takes pi, upper limit is pi. So cos pi is, what is the value of cos pi? It is minus 1. So t is minus 1. So t varies from 1 to minus 1. When x varies from 0 to pi, t varies from 1 to minus 1. So 1 to minus 1. What is sin x dx? Minus sin x dx is dt. Therefore, sin x dx is minus dt. Divided by 1 plus cos x is t. So cos square x is t square. So what are you getting? Minus 5 by 2 integral minus 1 to 1 dt by 1 plus t square. By using properties, we can simplify your problems as much as possible. Here, now again, we are going to use the property because see the function, see the integral 1 over 1 plus t square. This is an even function of x because if you replace t by minus t, what you will get? What is your the function? F of t is 1 over 1 plus t square is the given function. So now I am going to replace t by minus t. So f of minus t equals 1 by 1 plus minus t the whole square. Minus t the whole square. So this is again 1 by 1 plus t square. Okay, 1 by 1 plus t square. Therefore, it is an even function of t. Even function means how you write 2 times integral 0 to 1. So 2 times integral 0 to 1, 1 over 1 plus t square. 2 times integral 0 to 1, 1 over 1 plus t square dt. Already we have pi by 2 outside. So this 2 and 2 will get cancelled. So what I am having? Pi integral 0 to 1, 1 by 1 plus t square. How to integrate this? What is the formula? It is of the form integral dx by a square plus x. What is integral dx by a square plus x square? It is 1 by a tan inverse x by a formula. Here a is 1. So 1 by 1 tan inverse, what is the variable here? T. So tan inverse t by 1. Tan inverse t by 1 is tan inverse t. Now substitute the limits between the limits 0 and 1. So if you substitute, what you'll get? Tan inverse 1 minus tan inverse 0. This is what? Tan inverse of tan, for what angle you get 1 tan pi by 4. Tan 45 degree is 1 minus tan inverse of, for what angle this is 0, tan 0 is 0. Okay, so tan inverse of 1 is replaced by tan pi by 4 minus tan inverse of 0 is replaced by tan 0. This tan and tan inverse cancel. This is also cancelled. So pi by 4 minus 0. So what are you getting? Pi square by 4. You will understand? Are you all able to understand the problems? Have any doubts? Have any doubts in this? See the next problem. Evaluate integral minus 1 to 1 sine power 5x cos power 4x dx. Combination of sine and cosine. So what is your f of x? Sine to the power 5x cos to the power 4x. The limits are minus 1 and plus 1. Now you check that whether the given function is odd or even. For that, we have to replace x by minus x. So what you'll get? Sine to the power 5 of minus x, cos to the power 4 of minus x. Sine power 5 of minus x is minus sine power 5x. Cos power 4 of minus x is cos power 4x. Because cos of minus theta is cos theta and sin of minus theta is minus sin. So this is actually minus, what is sin to the power 5 cos to the power 4? It is f of x, so minus f of x. So what I'm getting is f of minus x equal to minus f of x. F of minus x equal to minus f of x means f of x is an odd function of x. F of x is an odd function, then the integral value is 0. So you don't need to integrate. Okay, that's why I'm telling, when you see the problem, you have to check whether we can apply any property here, that you have to check. That is the most important thing. Okay, in the first step, you have to check whether we can apply any property. First, you check that the given function is an even function or an odd function. That is to be verified first. Okay. Suppose the given function is an odd function, then the value of the integral is 0. So you need not to evaluate the given integration. You can write the answer directly. So this will be part A, that is objective type questions. So you have to be very careful while you are doing that. Next problem is evaluate integral 0 to pi by 2 sine to the power 4x by sine power 4x plus cos power 4x dx. Okay. Here the limits are 0 to pi by 2. So it is in the form integral 0 to a f of x dx. Integral 0 to a f of x dx. So what property will you use here? Zero to a f of x dx. 0 to a f of x dx is 0 to a f of a minus x dx. That is the problem. Okay. So what is your a? A is pi by 2. A is pi by 2. So you have to replace x by a minus x. That is x by pi by 2 minus x. So wherever you have x, it is to be replaced by pi by 2 minus x. So sin to the power 4 of pi by 2 minus x divided by sin to the power 4 pi by 2 minus x cos to the power 4 pi by 2 minus x. Pi by 2 is 90 degree, right? So sine of 90 minus theta is cos theta. That we know. Sine of 90 minus theta is cos theta. So we'll get cos to the power 4x. And sine of 90 minus theta is cos. Cos of 90 minus theta is sine. So cos power 4x plus sine power. Adding 1 and 2, what is 1? This is 1. So I plus I is 2i in the left hand side. In the right hand side, you will get integral 0 to pi by 2 sine power 4 plus cos power 4 in the numerator divided by the denominator will have cos power 4 plus sine power 4. This will get cancelled. Okay. Add these two. I plus I. 2i. It gives 2i. Then sine power 4 plus cos power 4. Same limits, right? So 0 to pi by 2 sine power 4 plus cos power 4. Divided by sine power 4 plus cos power 4. Cancel. We get dx. Integral dx is x. Substitute the limits 0 to pi by 2. So pi by 2. 2i value is pi by 2. Therefore, I value is pi by 2. Any doubts in this? Do you have any doubts? If you have any doubts, you can ask me now. Clear to you all up to this? If you don't have any doubts, then I'll wind up the session. We'll see you in the next class.
This conference will now be recorded.